Unit 1, Lesson 8, Notes 9, Interpreting Graphs of Functions, Day 1. Interpret intercepts and symmetry. To interpret the graph of a function, estimate and interpret key features. The intercepts of a graph are points where the graph intersects an axis. The y-coordinate of the point at which the graph intersects the y-axis is called the y-intercept. Similarly, the x-coordinate of the point at which the graph intersects the x-axis is called the x-intercept. Identify each function as linear or nonlinear, then estimate and interpret the intercepts. Letter A. The graph below shows the height y of an object as a function of time x. So we need to take a look and see, first, is this linear or nonlinear? Remember, linear means a straight line. It's clearly not a straight line, so we would call this nonlinear. And then we need to determine its intercepts and interpret them. So let's go ahead and start with the x-intercept. The x-intercept is where it crosses the x-axis. The x-axis is the horizontal axis, and it crosses right about here. It looks like the boxes are counting by ones, so this would be 7 would be here. We would say it's probably about 7.2, I would guess. And this is just an interpretation, it's just an estimation. So the x-intercept, we're going to put this symbol here, which means approximately, and we're going to say approximately 7.2. But what does that mean? We have the height of a launched object. That's the title of our graph here, height of a launched object. So an object was launched, went up in the air, and then came down. This represents, the y-axis represents the height. Well, the height here would be 0. So if I throw something in the air, and at 0 height means that it reaches the ground. And how long does it take to reach the ground? 7.2. So let's go ahead and write that out. So for the x-intercept, the object hits the ground at about 7.2 seconds. And that's my interpretation for the x-intercept. The y-intercept is where it crosses the y-axis, and the y-intercept is here. It looks like our boxes are counting by tens, so this is 20, 30, 40, and so on. So it's between 20 and 10, so I would go even, looks about halfway, maybe a little more, so 16 will approximate it at. So the y-intercept is approximately 16. And what does that mean? Well, the y-axis represents the height. So at time 0, the height is 16 meters. So that means the object starts at a height of 16 meters. So let's go ahead and write that down for our interpretation. The height of the object when it was launched was about 16 meters. Go ahead and try letter B. The graphs of some functions possess line symmetry. Symmetry is a geometric property that can be folded and each half matches the other exactly. Describe and interpret any symmetry. Letter C. An object is launched. The graph shows the height y of the object as a function of time x. So we want to imagine taking this graph and folding it in half. And we would want it to be the same on both sides. So if you take a look at our little pink vertical line there, if I fold the graph along that line and crease it, it would match it perfectly to the other side. So we would say that yes, this has line symmetry, and in fact, it's a vertical line symmetry. So let's jot that down. We have a vertical line, or just vertical line symmetry. And we want to say where it is. So our vertical line symmetry, let's take a look at our x value. The vertical line is between 3 and 4, we'll say about 3.5. So at about 3.5 seconds. And let's interpret that. So again, we're launching an object. We're throwing it up in the air. And then obviously the object, due to gravity, will fall down and hit the ground. Okay? So what it's really showing us with this line symmetry is that the time it took the object to go up is equal to the time it took to come down. So let's go ahead and jot that down as our interpretation here. So the time it took the object to go up is equal to the time it took to come down. Letter D. The graph below shows the change in temperature y of an object over time x. So is there any sort of line that you can draw, vertically or horizontally, that would make the graph match on either side? So let's draw a line. Okay. So we have our line. And let's see if anywhere it would be symmetric. If I were to put the line here, right in the middle, and I fold on that line, it wouldn't be symmetric. The graph would be going in different directions. So let's try and do a horizontal line. So let's go ahead and draw a horizontal line. If I put this somewhere in the middle, would it be symmetric? The answer is no. So this graph actually has no symmetry. And since it has no symmetry, there is nothing to explain or describe. Interpret positive and negative behavior. A function is positive where its graph lies above the x-axis and negative where its graph lies below the x-axis. If you take a look here, what's drawn in blue is everything above the x-axis, which means that's where the graph is positive. And everything drawn in red is below the x-axis, which means that's where the graph is negative. So for letter A, estimate where the function is positive and negative. Okay, so we are looking at that x-axis, and I'm going to go ahead and highlight the x-axis as best as I can. Maybe a different color here. Still pretty light. There's our x-axis. Everything above the x-axis is positive, and everything below the x-axis is negative. So we have that it's above the x-axis from 0 to what looks like maybe 3.2, and from 4.6 about and up, or 4.5 maybe and up. So it's positive between 0 and I believe we said 3.2, and let's label it with hours. And also positive at we'll go 4.5 hours or greater. So that's where it's positive. So again, it's positive from here to here and there to there. It's negative just in this section right here. So negative between, and I'm going to abbreviate between with BW. So negative between, I believe we use 3.2 and 4.5 hours. Go ahead and finish off B and C.